Okie dokies, artichokes. In this video, we're getting up close and personal with the paper. So, we have talked about slope, aka growth, and how to find that on a line that is graphed. Now, we are in the next couple lessons going to be starting to look at some scatter plots, which are technically graphed, but we're going to have to make up our own lines, which starts to get a little tricky, especially if we don't have any grid. So, a method we can do for finding the slope of a scatter plot is to take two of the random points from the scatter plot and find the slope. Or, there are several cases on the ISAT where you are only given 2 points and they ask you, what is the slope of this line? And you have to come up with it without graphing it. So, we're going to do that today. There is this handy-dandy little formula for slope if we are only finding, or if we're only using 2 points. You notice these little triangles here? The word for this triangle is delta. Triangle equals delta. It is Greek. Now the delta, and this is going to be consistent throughout the rest of your math and physics career, the delta equals change in. That's what it means. Change in. So when you see the little delta next to your y, what it means is change in y and change in x. And all that means is that we've taken two y's and we subtracted them to see what the difference is between. How did they change from one to the other? That's about it. So we're going to do that right now. I have an example for you. I have 2 points. These 2 points are on a line, and we're going to find the slope for that line. So what I have here is point 1 and point 2. You'll notice here that my y's have little 2's and 1's, and so do my x's. That's because x and y on point 1 is x1 and y1. And then x and y on point 2 is x2 and y2. Really important in this formula, you'll notice that y2 and x2 come first. They really need to do that, okay? Whatever your second point is, make sure it is y2 and x2 that come first. So if we take a look here, our change in y over our change in x equals y's go on top because y's are our vertical motion. So this is derived from that rise over run. Remember, rise comes first and is on top, and rise is vertical. So is y. We're going to take our y2, which is 11, and then we're going to take our x2, which is 5. And now we're going to subtract from that y1. See, y1 is 5. And then x1, which is 2. And if you ever forget what should go on top and bottom, just remember delta y, delta x, change in y, change in x. And now we're going to do the math. So 11 minus 5 is 6. 5 minus 2 is 3. In Nearpod, tell me 6 divided by 3 is what? Hopefully you said 2. And that's our slope. So in the formula, m would equal 2. That's it. Nice and easy. So let's do another one. I realize you guys are not used to using formulas. So I'll write out the formula again. y2 minus y1 over x2 minus x1. So the change in y and the change in x for these 2 points, x1, y1, and x2, y2, is what? We're going to find that out. So we're going to take y2 first, which is negative 6, and x2, which is 3. And then we're going to subtract from that y1, which is a negative 3, and x2, which is, or x1, sorry, which is 2. I am just all over the place with my talking today. Okay, this gets a little tricky. Right here I have a negative and a negative, which makes a what? Hopefully you said positive. I hope I've like ingrained this in your head. Fun fact, if you just connect the negatives, the parentheses in the negatives make a plus sign. How cool is that? So now we have -6 plus 3, which is going to give me a -3. And then on the bottom I have 3 minus 2, which gives me a 1. What is -3 divided by 1? Hopefully you said -3. Anything divided by 1, remember, is itself. So the slope, aka growth, of this line is -3. And that's how you can find the slope of a line without ever actually seeing the line, which is a huge component in the ISATs. So we're going to practice this today in the lesson, and then we're going to practice this again in our next lesson, which is all about how to find the line of a scatter plot. So, have a good day, everybody. Enjoy this nice short video, and I will see you in the next video. Bye-bye!